Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. The world of geometric symmetry really has two different styles of symmetry that they look at. There is the traditional line symmetry, but there's also rotational symmetry. And line symmetry is usually pretty quick for everyone to see. For example, let's kind of look at this shape right here, assuming I draw it well. Let's maybe, there we go. It's a little bit better. If I were to fold it in half on that spot, then the left side should match the right side. That would be line symmetry. However, I am not an art student. I did very poorly in art, so one of those limitations that I have. That's why I'm a math teacher by day, right? So line symmetry literally means if you fold it here, the two sides are going to match up. Sometimes it's easy to do if you take a transparency and you trace half of it and then you draw your vertical line and you flip it, doesn't match. Okay, rotational symmetry is, let's say you think of something kind of like a fan blade. Whoops, that was supposed to go the other way. We'll do it like this. We'll make it have petals. Now, if we were to rotate, in this case 90 degrees, we would find out that one petal made it to the next. I actually had this drawn up before, and they were just a smidge prettier. So basically, in this case, since this has 3 spots that it can rotate to, 360 divided by 3 is 120. So 120 and 240 are both angles of rotation for your rotational symmetry because you go every 120 degrees. And again, the line symmetry split it in two. So keep that in mind, that symmetry is very important and that we have to be able to physically, so if you grab transparency, which means a see-through clear thing, and you were to use a dry erase marker, you could spin it around the center point and it would continue to match up. So you can count lines of symmetry as well. So let's say you have a regular pentagon. So you can imagine what the pentagon looks like. Pentagon, because as I said, I'm not a super artist. But I could draw a line of symmetry from this point through the other side. That would be 1. Or from here through the other side. That would be 2, because see, it would fold. And from this point here, there's 3. And from this point here, 4. And from this point here, 5. There are 5 different lines of symmetry I could draw. Anytime I say regular, a regular pentagon means it has 5 sides the same and 5 angles the same. So anytime you see the word regular, and then they give you a shape name, it means you have congruent sides and you have congruent angles. And the pentagon that you would hear about from the military is definitely going to have congruent sides and congruent angles. You can pull it up on an image. Now, this one happened to also, besides the 5 lines of symmetry, this one actually happens to have 5 points of rotational symmetry as well. Because you could rotate around this simple point here in the middle, and we would get rotation. So if I take 360 degrees, which is a full circle, and I divide it by 5, I get 72 degrees. So every 72 degrees of rotation, or 72, 144, 216, and 288, then we're back to 360, right? Every 72 degrees puts us at a symmetrical point. So we had 5 lines of symmetry and 5 angular rotational symmetries. So keep in mind that some shapes have both line and rotational symmetry. Some are just one, some are just the other. And if I ever use the vocab word regular when you're watching one of my videos, I'm referring to something that has congruent angles and congruent sides. So a square would be regular, a rectangle would not be, because the rectangles doesn't have four sides congruent. So all your sides are congruent. Okay, so you can also have symmetry to a random point. Okay, so if we were to rotate this 180 degrees, rotate it upside down, it would map onto itself. And because of that, it has rotational symmetry to a point. Now, you did this before, so you have used this kind of idea and symmetry and line symmetry a lot. In elementary school, probably, when I was a kid, they had these books called Mad Libs, and they had like jokes and stuff, but then you could also have drawings. And they would have like a grid paper, and then they would have some kind of picture drawn on one side, and you would have to use symmetry to reflect it over and draw it to the other side. So you find symmetry in natures, you find it in flowers, you find it in faces. Really, when your teacher asks us something is symmetric, they're really just asking, could I rotate it? Could I fold it? Could I rotate it, not a full circle, but could I rotate it something else and have it map onto itself? Could I fold it somewhere and have it match up perfectly? So yeah, symmetry is great. You see it in art, things like that. So make sure that you understand how it works and that it also is a geometric concept, and you'll be a rock star.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.